Okay, so good day everyone. Welcome to another video on construction materials and testing. So in this video, we will be talking about the material, construction material which is aggregates. So in this video, we'll be talking about aggregate types and processing, the uses of aggregates, and ASTM specifications for aggregates. So let's start. So what is an aggregate? So aggregate is a combination of sand, gravel, crushed stone, slag, or other material of mineral composition. It is used in combination with a binding medium to form such materials as bituminous and Portland cement concrete, macadam, mastic, mortar, and plaster. Or alone, it is used in railroad ballast or filter beds. So, kapag wala siyang binding medium, it is a sub-base or subgrade material. So, ito, combination of mineral composition. So, aggregates play a very important role in the design and construction of highways and airport pavements. It is used as the underlying material upon which the pavement rests. So, it is the sub-base. They are also important as an ingredient in rigid and flexible pavements or structures. So, rigid structures, yung mga concrete structures natin, and flexible pavements is yung mga bituminous concrete natin. So, next we have aggregate types and processing. So, meron tayong iba't ibang types ng aggregate and iba't ibang pag-classify ng mga types ng aggregate. So, first we have here yung depende sa processing ng aggregates natin, it may be classified as natural or manufactured na aggregate. Natural aggregates are taken from natural deposits without change in their nature during production, with the exception of crushing, sizing, grading, or washing. Included sa mga natural aggregate is yung mga crushed stone, gravel, sand. So, yan yung mga common na natural aggregates natin. And we may also include yung mga pumice, shells, iron ore, and mga lime rock natin. So, these are natural aggregates. So, yung process niya lang na dito is yung crushing natin, sizing, grading, or washing. Kapag naman tinawag natin siyang, ang tawag naman natin sa kanya is manufactured aggregates kapag the aggregate of mineral origin resulting from an industrial process involving thermal or other modification. Kapag meron na tayong thermal modification sa ating aggregate or any other industrial process, it is already called a manufactured aggregate. So, excluded dito yung mga crushing kasi wala namang thermal modification doon. Pinapalitan lang yung size ng ating aggregate. Included sa ating mga or example ng ating mga manufactured aggregates is yung ating blast furnace slab, clay, shale, and yung ating mga lightweight aggregates. So, another classification ng ating aggregates is yung kanyang size. So, fine aggregate is defined as an aggregate passing a 3/8 inch or 9.5 mm sheave and most entirely passing a number 4 sheave and predominantly retained on the number 200 or 75 micrometer sheave. So, dito yung fine aggregate natin is we classify as ito, fine aggregate yung size ng ating fine aggregate is greater than number 200 sheave So, hindi siya magpapasa number 200 Sieve natin and it is less than number 4 Sieve. So, magpapas siya sa ating number 4 Sieve. Next is yung ating coarse aggregate. Coarse aggregate is defined as an aggregate retained on the number 4 Sieve. So, yung coarse aggregate natin is yung nasa coarse ang tawag natin sa aggregate na mas malaki yung size niya sa number 4 Sieve. So, hindi siya magpapasa number 4 Sieve natin. So, yan yung difference ng ating fine and coarse aggregates. So, yung definition ng fine at coarse aggregates na ito ay applied siya sa ating mga aggregates used as sub-base and sa aggregate natin na ginagamitan natin ng Portland cement na binding agent. So, kapag bituminous aggregates naman, iba yung definition ng ating mga coarse at saka fine aggregates. Iba yung dividing line niya. So, we will talk more about that later on. So, next we can classify yung ating aggregates depende sa kanyang gradation. So, we have here an open-graded aggregate. So, ganito yung kanyang graph. A well-graded aggregate is ito yung kanyang graph naman. Well-graded. For uniformly graded, ito yung graph niya. Gap-graded is itong graph na to. And for dense-graded, ito yung graph niya. Sorry. So, para mas maintindihan ninyo yung importance ng gradation ng aggregate, so tingnan natin dito. So, ito yung itsura ng mga aggregates natin. So, sa well-graded, filled yung mga voids natin ng mga maliliit na aggregates. So, maganda yung kanyang gradation kapag merong mga malalaki na aggregates and habang papaliit ang papaliit, meron din mas mga maliliit na aggregates na i-fill niya yung voids na hindi kayang i-fill ng ating mga bigger aggregates. Poorly graded is ito naman kapag dalawa lang yung aggregate size natin, isang malaki tsaka ganitong size. So, marami siyang voids. And then, kapag single size naman, syempre, ganito yung magiging itsura niya. Mas marami din voids siya. So, kapag well-graded is filled almost completely yung mga voids natin ng ating mga smaller aggregates. So, importante na hindi lahat ng aggregates natin is maliliit. So, importante pa rin itong mga malalaking aggregates natin kasi hindi siya magiging economical kapag lahat ng aggregates na ginamit mo is itong mga maliliit na aggregates. So, gradual gradation in size from coarse to fine is a key property of aggregates. So, aggregate gradation affects the workability of Portland cement concrete. So, sa gradation, iba-iba yung epekto nito sa ating mga paggagamitan ng ating aggregate. So, kapag Portland cement concrete, it affects the workability of Portland cement concrete. Kapag naman ginamitan natin siya ng bituminous concrete na binding agent, it will affect the stability and durability of the bituminous concrete mix. And then, ang effect niya naman sa ating mga base course, kapag wala siyang binding agent, it will affect the stability, drainage, and the frost resistance of the base course. So, yun, yung effect ng aggregate gradation sa iba't ibang uses ng ating aggregate. So, another classification is it may be rounded or angular. Gravel and sand are naturally rounded aggregates, whereas while crushed stones are angular. So, yung mga natural aggregates natin usually is mga rounded aggregates. Kapag trinash mo na yung mga natural aggregates natin is it will be forming angular na aggregates. So, yung angular aggregates is it helps in the binding. Kapag gumamit ka ng binding agent, nakakatulong yung mga angular aggregates kasi mas kumakapit yung ating binding agent. So, yun yung rounded and angular. So, yung rounded, okay lang naman yung mga rounded natin. Basta ang importante talaga is yung ating gradation. Mas importante yung gradation kesa kung rounded ba yung aggregate mo or angular. Pero mas nakakatulong pa rin naman yung pagiging angular niya kasi yun nga, mas makapit yung binding agent niya. Mas may pagkakapitan yung mga Portland cement or bituminous mix natin. So next, we have the aggregate processing. The main fundamental rule of good aggregate processing is to obtain aggregates of the highest quality at the least cost. Each process is completed with these objectives in mind. The processes include but are not limited to first yung ating excavation. So excavation is the removing of the overburden or yung mga nasa syempre kapag kumuha ka sa site, hindi naman purong aggregate lang yung makukuha mo, meron pa rin mga soil material. So removing of the overburden or yung mga excess material natin is yun yung excavation process natin. And then next we have here yung ating transportation. Mula sa ating excavation site, we need to transport our aggregate sa ating processing plant. So that is the transportation is the moving of the aggregates. And then for washing, we need to wash our aggregates kasi kapag sa excavation process lang is yung malalaking overburden lang yung mga matatanggal. Kaya meron pa rin mga matitirang mga maliliit na deleterious material or waste na kailangang matanggal doon. So, sample is yung mga clay or yung ating mga sieve. So, washing will help that. So, it is in washing na nare-remove yung ating mga deleterious materials. And then for crushing is we do this to reduce the size of the aggregates. So kapag boulder yung nakuha mo, na aggregate mo, you need to crush it para maging aggregate siya. And then for sizing is it is used for the size classification. So gumagamit tayo dito ng ating mga sheaves. So dito na ginagawa yung ating tinatawag na yung gradation. So, in sizing natin. So, yan yung mga iba't ibang process na nag-a-undergo yung ating mga aggregate. Okay, so next, let us take a look at the uses of our aggregates. So, first, kapag wala siyang binding agent, it is used as a base coarse material or other term for this is gravel bed. So usually ito yung tawag sa kanya, gravel bed. So base courses serve a variety of purposes depending upon the construction, practices, and the environment. They serve to provide structural capacity to bituminous concrete slabs and drainage for the Portland cement concrete slabs, and it lowers the susceptibility to frost. So again, as I've stated kanina, gradation is a key factor in the success of a aggregate as a base course material. So importante talaga yung gradation sa ating aggregate bilang base course material or kapag gumamit ka ng binding agent na bituminous concrete, so as a bituminous mixture, And kapag naman gumamit ka ng Portland cement, it is very important talaga yung ating gradation. So, next use of an aggregate is for Portland cement concrete. So, aggregate properties for Portland cement are in many cases different from aggregates used for base courses or for use in bituminous concrete. Aggregate gradation becomes a key factor. So, yun talaga, very important itong gradation. Becomes a key factor as it controls the workability of the plastic concrete. Further, the aggregates used in Portland cement concrete are a blend of fine and coarse aggregate to achieve a economical mix. So, hindi naman pwedeng puro fine aggregates lang para compacted yung ating aggregates. Kailangan din ng ating mga coarse aggregate para maging economical yung ating mix. For coarse aggregate, in the same definitions apply as previously given. So, yung coarse tsaka fine natin is the line between the coarse and fine aggregate is yung ating number 4 sieve. So, ito yung line between coarse and fine. So, kapag mas malaki sa number 4 sieve, so ito ay coarse aggregate. Kapag naman mas maliit sa number 4 sieve, so mas malaki yung number 4 sieve natin, yung butas. So, kapag nag-pass through sa number 4 sieve, it is a fine aggregate. So, for fine aggregate, the same definition as previously given is applied. But we introduce a new term. So, ito is yung fineness modulus. So, the fineness modulus, which denotes the relative fineness of the sand, is defined as 100 of the sum of the cumulative percentages held on the standard sheaves in a sieve test of sand. 6 sheaves are used in the determination. So, numbers 4, 8, 16, 30, number 50, and number 100 sheave. The smaller the value of the fineness modulus, the finer the sand. The fineness modulus for a good sand should range between 2.25 and 3.25. So, paano yung pag-compute ng ating fineness modulus? So, ito siya. Yung ating fineness modulus. So, ang ginagawa natin dito is we will take a look at the weight retained. So, yung test sample para sa test na to is it has a total weight of 1,000. So, I think this is in grams kasi ano to, fine. So, 1,000 grams. And then, ang weight retained sa ating number 4 sheet is 90 grams. And then, for number 8, we have 100 grams, 120 for number 16 sheet. For number 30 sheet, meron tayong 160 grams and so on. And then, we will do next is yung ating cumulative. So, para sa cumulative weight retained, para makuha itong mga values na to, ito lang yung given actually dapat. And na-compute na kasi itong table na to. Para makuha itong cumulative, una is isulat lang natin yung ating ito, yung individual weight retained sa number 4 sheet. So, ito siya, number 90. And then, para makuha natin itong 190 dito, i-add mo yung weight retained sa susunod na sheet from yung last na cumulative natin. So, this will be 90. Itong 90 na to plus 100, this will be equal to 190. Para sa susunod, itong 190 plus itong 120, this one will be equal to 310. And same process lang. 310 plus 160 for 70. For 70 plus 140 is 610. And 610 plus 140 is equal to 750. So, ayan, yung ating cumulative weight retained. So, after nyan is, gagawin natin is cumulative percent retained. So, paano naman ito? So, para ma-compute natin ito, this one will be equal to itong cumulative weight retained, which is itong 90. Divide lang natin siya sa ating total weight. So, 90 over itong value nito over 1,000. And then, it should be in percentage. So, dapat times 100%. So, this one will be equal to 9%. And then, ganun yung sa susunod over 1,000 multiplied by 100%. So, hanggang sa makuha nyo lahat ito. Pag nakuha nyo na yan, take the summation and divide it by 100, and yun yung makukuha nyo na fineness modulus. So, sabi kanina, a good sand should have a range between 2.25 na fineness modulus and 3.25. So, yung fineness modulus nito is 2.42. So, it is a good sand. Kasi it is within the range na 2.25 and 3.25 yung kanyang fineness modulus. So, next, for bituminous mixtures, the influence of aggregates on the properties and performance of bituminous mixes is great. The ideal aggregate for a bituminous mix would have proper gradation and size, strong and tough, and be angular in particle shape. Other properties would consist of low porosity, surfaces that are free of dirt, rough texture, and hydrophobic nature. So, ito yung ating bituminous mix. So, sabi ko kanina, yung number 4 sheet is the line between the coarse and fine aggregates para sa ating Portland cement concrete, and same din para sa ating base coarse na aggregates. Para sa bituminous mixture natin, hindi yun yung dividing line. For bituminous mix, the dividing line between fine and coarse aggregates is 3/8 inch na sheave or yung 9.5 mm sheave natin. So, yun yung dividing line between the fine and coarse aggregate. Hindi yung number 4 sheave natin. Iba yung sa ating bituminous mix. Okay, so next we have here the ASTM specifications for aggregates. So first of all, yung ASTM, it stands for American Society for Testing and Materials. Another na standard for testing na specifications is yung AASHTO. So AASHTO stands for American Association of State Highway and Transportation Officials. So yun yung ating mga basis sa mga test na ito. So, first of all, we have here the specific weight and water absorption test. So, we have here yung Astm C1131 or the specific gravity and absorption of coarse aggregate. The purpose of this specification is to determine the solid volume of coarse aggregate and the unit volume of the dry rotted aggregate such that a weight volume characteristic can be determined so that a concrete design mix can be determined. The bulk specific gravity is used to determine the volume occupied by the aggregate. So yung equivalent nitong Astm C1127 sa ating AASHTO is AASHTO T85. So same lang yung Astm C127 at AASHTO T85. So, yung gamit nitong specific gravity is kailangan natin to kapag gagawa tayo ng ating concrete mix. Siyempre, kapag gumawa ka ng concrete mix, kailangan mo is yung volume. Pero pag maghahalo ka naman na, hindi mo naman masisigurado na yung say for example, yung ginamit mo is gumamit ka ng kahon na to makuha yung volume na kailangan mo ng coarse aggregate mo, hindi mo naman sigurado na yun talaga yung eksaktong volume. So, pwedeng gawin mo is yung kunin mo yung kanyang specific gravity and convert mo yung volume na kailangan mo to weight. And then yung weight, yung kukunin mo na lang na measurement ng coarse aggregate mo. So, ganun. Yung gamit nitong makukuha natin na data sa test na ito. So, panoorin na lang natin yung video para makita natin kung paano i-perform itong test natin na ito. So, next, we have here yung video.
Welcome to the CTTP training videos. Astm T85, Specific Gravity and Absorption of Coarse Aggregate. This video outlines the steps to prepare a sample for testing. Obtain a representative field sample. Dry the sample to a constant mass at 230 plus or minus 9 degrees Fahrenheit. Remove the sample from the oven and cool to room temperature. Process the sample over the appropriate sieve, which is typically the number 4 sieve.
So, yung test na ito is, ito pa lang yung preparation for the test. So, kailangan i-sieve sa number 4 sieve kasi yung magpapass through sa number 4 sieve is fine aggregate na. And yung test na ito is for specific weight and water absorption ng ating coarse aggregate. So, dapat yung hindi magpapass sa number 4 sieve yung kailangan natin na sample. So, ayan.
Discard any aggregate passing the sieve.
So, yan yung mga fine aggregates na kasi.
Ensure that the test sample meets minimum sample size requirements. Wash the sample to remove dust or other coatings from the aggregate. Completely cover the aggregate with water. Allow it to soak for 15 to 19 hours. Please visit our website at cttp.org
for the sample. So, ito yung test for the specific weight and water absorption ng ating coarse aggregate.
Welcome to the CTTP training videos, Specific Gravity and Absorption of Coarse Aggregate. Prepare a scale and water bath for testing. Adjust the water temperature to 73.4 plus or minus 3 degrees Fahrenheit and unplug circulators. Center the scale for weighing below without interference. Fill the water bath to overflowing and allow it to stabilize. Drain excess water from the aggregate. Bring all aggregate particles to a saturated surface dry or SSD condition. Dry aggregate surfaces with an absorbent cloth until all visible films of water are removed. Particles should appear damp but not shiny. This portion of the aggregate is now at SSD condition. Place the aggregate in a bowl and cover with a damp towel to maintain SSD condition. Repeat the drying process until all aggregate is at SSD condition. Tare a bowl on the scale. Transfer aggregate to the tared bowl and record the SSD weight of aggregate.
So, sa pag-record niya ng weight na to is naka-zero itong weighing scale kapag nandito yung container na to. So, yung makukuha mo na lang na weight dito is yung weight ng ating sample. So, hindi na included yung weight ng tawag dito, container na ito.
Remove the sample from the top of the scale and submerge the basket into the water bath with a twisting motion. This removes any air bubbles trapped in the basket. Allow the water level to stabilize. Then tare the basket underwater using the weigh below device. The scale should read 0 with the basket attached to the chain.
Para yung makukuha na weight na is hindi mo na kailangan
Transfer the SSD aggregate to the basket. Submerge the sample in the basket with the twisting motion.
So, important yung twisting motion na yun para tumaas lahat ng tawag dito, air voids na nandito sa ating sample.
The water level to stabilize. Record the submerged weight of aggregate. Next, transfer the aggregate to a bowl. Dry the sample to a constant mass at 230 plus or minus 9 degrees Fahrenheit. Cool to room temperature. Record the dry weight of aggregate. Specific gravity and absorption values can now be calculated, including the apparent specific gravity, bulk specific gravity based on the SSD condition, and absorption capacity.
So, based sa mga nakuha natin na data, pwede na natin i-compute yung ating apparent specific gravity, bulk specific gravity, and yung bulk specific gravity na basis natin is yung SSD condition, and yung ating absorption. So, water absorption niya. So, ito, magra-round off tayo dito sa nearest 0.001 sa ating tatlong ito. Tapos, 0.1% naman sa ating absorption.
Specific gravity values should be reported.
So, ito yung formula for the, para makuha natin yung mga specific gravity and yung kanyang water absorption. So, try na lang natin na gawan to ng sample using yung nakuha natin na given sa video kanina. So, yung weight of the oven dry specimen in air in grams is, so yung nakuha kanina is 4,018.2 grams. And then, dito naman sa ating B, the weight of the saturated surface dry specimen in air is 4,045.6 grams. And then for the weight of the saturated specimen in water, this one is 2,479.4 grams. Ito yung nasa video kanina. So to compute for the bulk specific gravity, that would be equal to A. Yung A natin is ito, weight of the oven dry specimen, 4018.2 all over B, which is 4045.6 minus yung ating C, which is 79.4 grams. So this one will be equal to, so round off to 3 decimal places, so 2.566. So walang unit ang ating specific gravity. So yan. So for the next one, we have here B. Same lang yung nasa baba natin. Papalitan lang yung nasa taas. B is 4045.6 all over 4045.6 minus 2479.4. So this one will be equal to 2.583. And the next one is ito, apparent specific gravity. So this one is A, 4018.2 all over A, 4018.2 minus C, which is 2479.4. And this one will be equal to 2.611. And then for the last one, we have here the water absorption is the weight of the surface dry specimen. So 4045.6 minus yung weight ng ating oven dry, 4018.2. So makukuha mo na yung weight ng water all over the weight of the specimen. So 4018.2. And then yung absorption natin is in percentages, so times 100%. Sorry. So this one will be equal to 0.7%. So 1 decimal is yung percentage natin. So yan yung ating test for the specific weight and water absorption of coarse aggregates. So next we have here the test for the specific gravity and water absorption of fine aggregates. So yung ASTM specification niya is Astm C1131. The purpose of this specification is to determine the bulk and apparent specific gravity of fine aggregate as well as the absorption. Yung equivalent na AASHTO specification niya is AASHTO T84. So AASHTO T84. So let us watch the video for the test for the specific weight and water absorption of fine aggregates. Magkaiba yung test for coarse and fine aggregates. Hindi sila magkapareho. Kasi hindi kapag nilagay mo sa ward mesh basket yung fine aggregates natin, lalabas lang siya doon. So matatapon. So iba yung test natin for fine aggregates. So let's watch the video.
Welcome to the CTTP
Yung
training
unang part ng
videos.
video is yung preparation
Astm
pa lang. So, itong video na to.
C1131, specific gravity and absorption of fine aggregate. This video outlines the steps to prepare a sample for testing. Obtain a representative field sample and reduce it to an appropriate size for processing. Dry the sample to a constant mass at 230 plus or minus 9 degrees Fahrenheit. Remove the sample from the oven and cool at room temperature. Process the sample over the appropriate sieve, which is typically the number 4 sieve. Discard any aggregate retained on the sieve. Keep approximately 1,000 grams of the fine aggregate for testing. Add at least 6% moisture to the sample. Place the sample in a sealed container and mix to distribute moisture. Allow the sample to soak for 15 to 19 hours. Please visit our website
So,
at
yun yung preparation
cttp.org for other
to
training
achieve
videos
the
and
SSD
modules.
condition. So, kakailanganin kasi yun for
Welcome to the
this.
CTTP. Discard any aggregate retained on the sieve. Sealed container.
So, yun yung preparation.
Welcome
next,
to
we
the
have here
CTTP
yung,
fine aggregate.
test.
Fill the pycnometer to the calibration mark with water at 73.4 plus or minus 3 degrees Fahrenheit. The bottom of the meniscus should be on the pycnometer's calibration mark. Ensure that no excess water is present on the outside of the pycnometer or in the neck. Record the weight of pycnometer filled with water to the calibration mark. This is referred to as the pyc plus water. Remove about half of the water and place a funnel in the pycnometer. Temporarily set it aside. Perform a cone test to verify the moisture condition of the aggregate. Fill the cone until it is overflowing. Apply 25 drops from 0.2 inches above the aggregate level. Remove aggregate from around the base of the cone while holding the cone firmly in place. Lift the cone straight up. For the first cone test, the aggregate should be wetter than SSD. If the aggregate is wetter than SSD condition, the material will retain the molded shape. Dry the aggregate by stirring and blowing warm air. Run cone tests periodically until the SSD condition is reached. If the aggregate is drier than SSD condition, the material does not maintain any molded shape. If the aggregate is dried past SSD condition, add water, cover, and allow it to stand for 30 minutes before continuing. Then repeat the cone test. The goal is to gradually dry the material so that it approaches the SSD condition as determined by the cone test. At SSD condition, the material slumps slightly, but a portion of the cone stands. Note that materials with a high percentage of fines may slump on one side only. Tare the pycnometer with the funnel. Promptly add 500 plus or minus 10 grams of SSD aggregate. Record the weight of SSD aggregate that was added to the pycnometer. An optional step in this test is to get a companion or second SSD sample. This sample is used as a substitute SSD sample that can be dried more quickly. If using a companion sample, the aggregate weight must be within plus or minus 0.2 grams of the original SSD weight. Dry the companion sample to a constant mass
So,
at
yan
230
is yung
plus or minus 9 degrees.
backup na sample natin. So, para mas mabilis yung pagtetest is nauna ng deny ito para habang tinetest yung sample natin is hindi na masyadong matagal yung pag-aantay para makuha natin yung dry weight ng ating sample. So, pwedeng gawin ito.
Degrees Fahrenheit.
Pwede rin
Go
yung
back
sample
to the
mismo is kapag tapos na kayo dito sa test, yun yung i-dry ninyo. Pero medyo matagal yon kasi sobrang dami yung tubig niya dito. So, maganda na meron tayong backup na sample para yun na lang yung kukunan natin ng dry weight. So, equal lang din naman yung weight ng sample na nailagay dito tsaka yung weight ng sample na drenay natin.
Pycnometer and fill it to approximately 90%. Rinse any aggregate trapped on the funnel or neck during this process. The funnel can now be removed. Roll and agitate the specimen to eliminate all air bubbles in the pycnometer. This can take some time, 15 to 20 minutes on average.
So, dapat wala ng air bubbles kapag itetest na natin siya.
Ensure that the
i-roll
water
and agitate
temperature is 73.4
hanggang mawala
plus
na
or
yung
minus
air
3
bubbles
degrees
na
Fahrenheit.
tumataas.
Fill the pycnometer to the calibration mark. The bottom of the meniscus should be on the calibration mark labeled on the pycnometer. Ensure that no excess water is present on the outside of the pycnometer or in the neck. Tear the scale and record the weight of the pick plus water plus sample. If a companion sample was not obtained, empty the contents from the pycnometer
Yan,
and
kapag
dry to
hindi
constant
kayo
mass.
nakakuha ng companion sample, so pwedeng
Collect all aggregate
sample
and
na lang
water
yung
from the
i-dry ninyo.
pycnometer. Rinse until the pycnometer is clean. All aggregate must be removed from the pycnometer. Dry the sample to a constant mass at 230 plus or minus 9 degrees Fahrenheit. Cool to room temperature. Record the dry weight of the aggregate. Specific gravity and absorption values can now be calculated, including the apparent specific gravity,
makakalculate na natin yung ating apparent specific gravity, bulk specific gravity, and yung ating water absorption. So, dito tayo magra-round off 3 decimal places sa tatlong to. Tsaka dito sa water absorption is 1 decimal place sa na naka-percentage. Ayan.
Bulk specific gravity. Welcome to this.
So, ito yung ating formula for the bulk specific gravity, apparent specific gravity, and yung ating water absorption. So, base sa mga nakuha nating data kanina, let us try to do this as an example. So, yung A natin is yung weight of oven dry specimen in air. So, yung weight ng oven dry specimen was 497.5 grams. And then, next is yung weight of pycnometer filled with water. Yung wala pa yung specimen natin, that was 1,261.5. So, yung weight niya up to the calibration mark yung water content niya. And then, the weight of pycnometer with specimen and water to the calibration mark is 1571.9 grams. And then, last is yung weight ng saturated surface dry specimen natin in air. That is 501.6 grams. So, yan yung mga nakuha natin sa test natin. So, we may now compute for the bulk specific gravity. That is A, yung ating oven dry weight. So, 497.5 all over B, which is 1261.5 plus S, which is 501.6 minus C, yung weight na to, 1571.9. So, yung makukuha natin dito kapag kinalculator natin is 2.602. Next, we have here bulk specific gravity in SSD condition. So, papalitan lang natin yung nasa taas ng saturated surface dry na weight. So, 501.6 all over 1261.5 plus 501 minus 1571.9, and that would be equal to 2.623. And next, we have here yung apparent specific gravity natin. So, 497.5 all over. So, B is 1261. 1261.5 plus A, 497.5 minus C, 1571.9, and that would be equal to 2.659. So, last, we have here yung water absorption niya. That would be equal to S minus A, so 501.6 minus 497.5 all over yung ating A, so 497.5, and that multiplied by 100%, that would be equal to 0.8% yung kanyang water absorption or yung kanyang moisture content. So, yan yung test for the specific weight and water absorption or the moisture content of fine aggregates. So, next test is the Astm C1131 or the resistance to degradation of small size coarse aggregate by abrasion and impact in the Los Angeles machine. The purpose of this specification is to test the coarse aggregate smaller than 1.5 inch for resistance to abrasion using the Los Angeles testing machine and to evaluate the base coarse aggregates for possible degradation. So, ito is importante yung abrasion resistance para sa ating base coarse aggregates kasi. So, Astm 131 yung kapareho niya sa AASHTO is AASHTO T96. So, yun yung equivalent na testing niya. Testing specification niya for AASHTO. So, ayan. So, panoorin natin yung video for the test for abrasion.
EAA 304, Highway Engineering Laboratory. Los Angeles Abrasion Test. Welcome to Highway Engineering Laboratory. This video describes step-by-step procedures to conduct Los Angeles Abrasion Test for aggregate. Theoretically, this test measures aggregate toughness and abrasion resistance such as crushing, degradation, and disintegration. The aggregates used as a wearing course of the highway pavements are subjected to wearing due to movement of traffic. When vehicles are moving, the soil particles present between the inflated tires and road surface cause abrasion of the aggregates. For that reason, the aggregates should be hard enough to resist abrasion. The Los Angeles test simulates the abrasive action by use of standard steel balls when mixed with aggregates rotated in a drum for specific number of revolutions. The Los Angeles abrasion test for aggregate is conducted using Astm C1131 standard test method for resistance to degradation of small size coarse aggregate by abrasion and impact in the Los Angeles machine. Objective: to determine the hardness of aggregate that used in highway pavement, and to evaluate the resistance of coarse aggregate against abrasion and mechanical degradation during handling, construction and use. The main apparatus required are steel spherical balls, sieves, and Los Angeles abrasion test machine. Procedure: place coarse aggregate with predetermined mass, around 5 kilograms, M1, into a steel cylinder of the Los Angeles testing machine, having an inside diameter of 711 mm and inside length of 508 mm. The machine is equipped with counter and shall consist of hollow steel cylinder closed at both ends. A specified number of steel balls, usually 6 to 12 steel balls as an abrasive charge, are then placed in the machine. Steel ball averaging approximately 44 to 48 millimeters in diameter, and having a mass between 390 and 445 grams each. Switch on the plug, in order to rotate the Los Angeles testing machine, at a speed of 30 to 33 rotation per minute, for 500 revolutions. The machine should be balanced, and driven such that there is uniform peripheral speed. After the prescribed number of revolutions, remove the steel balls from the machine. Collect the aggregates. Sieve the finer portion on sieve number 12, 1.70 millimeters. Determine the aggregate passing the sieve number 12, M2. Repeat this test for another sample from the same source. Determine the Los Angeles abrasion value for each sample of aggregate by comparing the retained mass to the original mass of the aggregate sample.
So, ito yung formula niya, yung mass of the retained mass to the original mass. So, ito yung retained mass and yung original mass ng ating sample. So, M2 over M1 times 100.
Record the average value to the nearest one.
So, yan yung ating abrasion test. Since wala siyang given na yung nakuha kasi kanina dito, around this part, yung nakuha kasi na weight dito is included itong weight ng ating container na ito. So, di natin alam yung weight ng sample, kaya wala tayong sample na pag-solve kung paano i-solve ito. Pero madali lang naman yung ano niya, yung formula niya, ito lang. So, M2 mass retained, yung mass retained over the original mass ng ating aggregate sample. So, madali lang naman yung formula.
Record the average value to the nearest.
So, next test is the unit weight ng ating aggregate. So, yung Astm C1131, yung bulk unit weight of aggregate. This method covers the determination of the unit weight of fine, coarse, or mixed aggregates. So, yung equivalent na specification nito sa ating AASHTO is AASHTO T19. So, AASHTO T19 and Astm C1131. So, panoorin natin yung video. So, itong first video nga pala is yung pagkuha lang ng volume ng ating container. So, yung pangalawang video is yung talagang test natin. So, importante ito kapag di mo alam yung volume ng container. So, papakita ko mamaya sa next video kung bakit importante yung gawin ito.
Welcome to the CTTP training videos. In this video, the determination of the volume of a measure is demonstrated as described in Astm C1131. Grease the rim of the measure to prevent leakage of water. Remove excess grease from the inside and outside of measure. Zero the scale. Place the empty measure and glass plate on the scale platform. Record the mass of the glass plate and empty measure. Fill the measure with room temperature
ganito
water.
yung gagawin nyo kapag di nyo alam yung volume ng container.
Measure the temperature of the water to the nearest 1 degree Fahrenheit. Finish filling the measure until the water level is slightly above the rim. Cover the measure with the glass plate to eliminate air pockets and excess water. Press down firmly. If any air pockets can be seen, remove the glass plate and start over. Remove any water that overflows onto the measure or glass plate.
Yung idea dito
Zero
is
the
yung
scale. Place
alam
measure
natin yung
filled with
unit
water
weight
and
ng
glass
tubig.
plate on the scale platform.
Para
Record the
makuha
mass
yung
of the
volume,
water, glass plate, and
base sa
measure.
unit weight.
Determine the density of the water based on the measured temperature.
Given naman na yung
Calculate
mass
the
ng
volume
tubig
of the
dyan,
measure by dividing the weight of the water
makukuha
by
na
the
yung mass
density
ng
of the
tubig.
water.
Kasi yung unang mineasure is yung mass
Report the volume to the nearest
yan yung
0.001 cubic
calculation.
foot.
So, given yung
Please visit our website at cttp.org for other training videos and
kapag alam
modules.
mo na yung volume ng container mo,
Welcome.
so pwede ka na mag-proceed sa test natin. So ito yung test. So say for example, yung container mo is hindi kaganda ng container. Say for example, ganito yung container na kukunin mo. So, ganyan yung container mo. So, di mo sure yung kanyang volume. So, pwedeng gawin mo is yung naunang video. Pero mas accurate yung volume mo kapag ginawa So, yan yung pagkuha ng unit weight ng ating tawag dito, unit weight ng ating aggregate. So, kapag nakuha mo na yung mga data mo, so gagawin mo na lang is, makukuha mo kasi dyan is yung mass. So, gagawin mo na lang is, mass multiply mo yung gravity divided by yung volume na nakuha mo sa naunang video, which is yung volume ng iyong container. So, makukuha mo na yung unit weight. So, kapag yung mass lang kasi yung ginamit mo dyan, ang makukuha mo is yung density ng iyong aggregate. So, madali lang. And then, sabi sa test natin is repeat 4 times, i-average mo na lang yung makukuha mong unit weight. So, yun yung test for the unit weight of aggregates. So, next is yung test for the uniformity of aggregates. So, yung ASTM nito is Astm C1131, Sieve or Screen Analysis of Fine and Coarse Aggregates. The purpose of this specification is to determine the particle size of fine and coarse aggregates to be used in various tests. So, yung equivalent na specification nitong ASTM C136 is yung AASHTO T27. So, let us watch the video for the Sieve analysis.
Welcome to the CTTP training videos. AASHTO T27, Sieve Analysis of Fine and Coarse Aggregates. Obtain a representative field sample of aggregate. Dry the sample to a constant mass at 230 plus or minus 9 degrees Fahrenheit. After drying, cool the sample to room temperature. Then record the dry weight. Ensure that the sample size meets specification requirements. Stack the sieves in order, with those having the largest openings on top. Transfer the sample to the sieve stack without loss of aggregate. Hand sieve the sample or use a mechanical shaker set to the calibrated time. After sieving, remove each sieve from the stack. Remove trapped aggregate from undersized openings. Empty each sieve and record the weight of material retained. During this process, check for overloaded sieves. Note that individual or cumulative weights may be recorded, and the method chosen will affect subsequent calculations. Use a soft paintbrush to clean finer sieves. This will prevent damage to the more delicate screens. Finally, record the weight of material in the pan. Calculate the percent retained and percent passing each sieve. Report the percent passing each sieve to the nearest 1% except the number 200 sieve. For this sieve, report to the nearest 0.1% for values less than 10 and to the nearest 1% for values greater than or equal to 10. Please visit our website at cttp.org for other. Welcome to the
So, yung formula for the uniformity of aggregates is ito. So, makakagawa tayo ng table using itong mga data natin. So, yung makukuha mo kasing data sa test is yung weight retained and yung weight ng sample. So, para makuha mo yung percentage retained is weight retained over the total weight of the sample multiplied by 100%. Next is yung cumulative weight passing. So, original weight minus the retained weight. So, ito naman, cumulative percentage passing, cumulative weight passing over the original weight times 100%. and then cumulative percentage retain is 100 minus the cumulative percentage passive. So, magagawa dito is yung table sa naunang part ng ating video. So, i-replay nyo na lang yung video na ito. So, nandun meron tayong table na magagawa kapag nag-perform tayo ng uniformity of aggregates na test. So, ayan. So, that will be all. Thank you for listening.